A quick demo on how to use Jupyter notebooks and how to work with the Python notebook that I provided for today's lecture. So let's start by opening a terminal, and then you can either launch Jupyter Lab from here, or you can navigate to the folder just using Mac. Windows people will have to figure this out on their own. So let's launch Jupyter Lab in this folder where I put the data. And I've already given you a script to start from. And what that script does is it loads a couple of modules, pandas as PD, numpy as NP, and matplotlib, so we can do some plots. And then let's load in the data, and let's just have a brief look. So I'm going to insert a new cell above with the command A, and then let's have a look at what is in our data set. As you can see, these are the first 5 rows indexed. The 0th row, that is the first row. And as you can see, there are some variables relating to the date, the hour, then we have a price and volume, and a couple of extra variables. And a good thing to always check is to see what are the data types of the incoming data. And as we can see, time string and date string is being written as an object, which means that it's just pandas doesn't know what it is. So these two commands here converts this variable to date time and return, and we just overwrite the variable. So now what we have is that the data types of the first 2 are date time objects. So if we look at the data frame, it looks exactly the same, but it means that if we take, for instance, date string here, which is now actually a date variable, we can use all kinds of things that are built-in functions such as dt, and we can extract the year from each of them. And we could do a quick cute little histogram to see which years do we have. It looks like we have the same years, or the same number of observations per year: 13, 14, 15, and 16. So this little cell here does some complicated stuff to do some plots. So let me just give you a quick feel for what it's doing. What we could do is we could just go dt dot and then yeah, let's do just plot and say x should be time, and it needs to be a string, and y should be the price. That's the first plot we can do. Alright, so it's showing us on the x-axis the date or the time, and it's formatting it as monthly, so that's nice, but we can see that there are a lot of observations and it's looking a little bit noisy. So one thing that we could think of doing is to do monthly aggregations, and the function group by does that kind of nicely for us. So we tell it, I want to group by the variable time string, group by pd.grouper key time string, and frequency, let's do annual frequency. And let's take the price, and this can give the means within years. And what that's giving us is that the average price in 2013 was 38 euros per megawatt hour, 29 and 14, and so on. Or we can do at the monthly level, and now we have January 2013, February 2013, and so on and so forth. And we can plot these, and pandas just naturally interprets that we want the index, which was the date, on the x-axis. And now I'm moving towards creating this nice graph, which is showing one variable on the secondary axis and one on the primary. But it's not too important with this plotting tool, so I just wanted to give you a feel for it. But we can see that prices are falling over time, but in particular here it has this strong fall in prices just as the volume falls. So maybe there's some correlation between price and volume. But let's move towards the exciting part, namely the regressions. So our dataset D comes in the form of a pandas data frame, and we can type d.info to get a little bit of information, we can see that it's 2.1 megabytes. There's a total of 8 columns, that is variables, and the index has 35,000 entries. So, and if we type d.shape, we can also see this information. There are 35,060 observations and 8 columns. So the first of those is what we would call n. So let's extract it, and that's what we do here. Now we have n in memory, and n is the number of observations. Then what I'm going to do here is I want to work with linear algebra, so I want to extract x and y. So let's just take these first 2 lines here and run them separately. Alright, I just ran that cell, and now I have x in memory. And maybe it's a little bit hard to read, so we can always type x.shape and see that x is n rows down and 2 across. So there's just, what I did was I stacked 2 things next to each other. First I took a vector of 1s, and I took the prices. And I stacked them along the first axis so that they're next to each other. If I didn't type stacking along first axis, then the default is stacking along the 0th axis. And what that results in is a matrix that's lying down, and that's kind of the opposite of what we normally use in this course. Also, an important thing to note is that when we're creating y here, then we take the variable volume from our data set and we extract the values. So if we just take d.volume, then this is not a numpy object, this is a pandas object. So if we type of this, we can see that this is a pandas object. And what we want to work with here to do linear algebra is we want to work with numpy. So we type .values to get the underlying data. And now we can see that the object that we have here is a numpy array. But the thing about this array in itself is if we type shape, we can see that it has only 1 dimension. And that's how Python thinks about vectors. They just have a length, so they're not lying down or standing up. They're just vectors with a 1 dimension. And we would like for it to be a vector that's standing up, that is a column vector. That's our default interpretation of y. And so what we do in order to get that is we use this command. We say dots, which tells it we want all the data, and then np.new axis. This is giving us now a vector which has 2 dimensions, n down and 1 across. So now this is a vector that's standing up. If we wanted it to be lying down instead, we do it like this. This is how we get a row vector out. And when we print it, we can also see that it's lying down. So that's how we use this argument np.new axis to take this existing vector. We could also do it in 2 steps if we wanted to, by first creating lowercase y and then afterwards saying, okay, now we want y to be expanded like so. So in this case, let's print the intervening y.shape, and then we override y here, and let's print y.shape. We can see that it's going from having only 1 dimension to having 2, where the second dimension is just 1. Great, so that's what we want. And now we're ready to start computing stuff. And here's the formula for how to do compute the OLS estimator. So let's start by noting that if we write x times x, numpy will actually do that. And what it's doing, how it interprets this symbol is it says, wow, you must mean element-wise multiplication. So in other words, if we print out x above, we can see that it says 31 point something here. And if we raise that to the power 2, which it's not allowing us to do, here's how we do it. Here's how this 2 stars is how we raise it to the second power. Alternatively, we could just enter it twice. We're getting 964, which is exactly what it says here. So writing x times x, that's giving us element-wise multiplication. And what we want is the matrix product. And if we try to do it like so, then that obviously doesn't work, because x is n by 2 and x is n by 2, so we can't multiply those two matrices. We have to transpose the first one. And this, ladies and gentlemen, is x prime x. So now we just have to invert it for the first part of the formula, and it would be tempting to raise it to the power -1, but that's not how it works in we have to do a linear algebra operation. So we invoke the linalg library under numpy, and we want the inverse. So this is how we compute x prime x inverse. And this is just a matrix. We can see what the shapes of it are. It's 2 by 2, exactly as we would expect. So we could multiply this by another matrix. We might want to try x. That obviously doesn't work because x has dimension n as its first dimension. So we need to transpose it. And this whole thing now has dimension 2 by n, so we can multiply it as a matrix product with y, which has dimension n by 1. And what the result is a vector that's 2 by 1. So that's how the formula for beta hat comes about. And what I'm doing in this final part here is to just put it into a nice table format. There are many ways of doing that. Here I'm giving it 2 numbers, and I'm telling it that out here in the index, I want a data frame out of it, and in the index I want you to write constant for the first number and price for the second number, because I remember that when I created x, I put a constant first and then the price. And there's just one column here. So I give it a list of names, and it just has one element in it, and that's beta hat. And that's one way of putting it here. And so in the final cell, I'm just creating a different x. Y is creating the same way, this time with a vector of 1s first, then the price, and then the temperature in Norway. And the formula for the OLS estimator is exactly the same as before.